Hello, eighth grade. Today we're going to begin solving rational equations. Now this is really going to involve all the skills you've learned all year. So let's get started. This first equation involves a fraction coefficient, a fraction as and fractions as constants. So one method that always works is to eliminate the fraction. And in this case, it's a fairly simple one to do that with because you might notice that 2 and 5 are factors of 10. And so we could make a common, or we could find that least common denominator, which would be 10. And if we eliminated all of them by multiplying each side by that least common denominator, so let's say we took 10 and we multiplied this side by 10 and this side by 10. Because 10 is a multiple of 2, 5, and 10, it would eliminate the fraction because it would simplify or cancel away. So let's use the distributive property. 10 times 1/2 is 5, so 10 times 1/2 x would be 5x. 10 times 3/10 would be 3. And that would be equal to 10 times 1/5, which is 2. And so now we have a simple equation that we just want to isolate the x to solve for it. So we subtract 3 from both sides, and we have 5x is equal to -1. Divide both sides by 5, x is equal to -1/5. So the next step would be to check our answer. And we talked about that recently, that we want to make sure that the solution that we come up with actually works. And so in this case, I would replace x with -1/5. And when I multiply 1/2 times -1/5, you get -1/10. And if you add 3/10 to that would give you +2/10, which is equivalent to 1/5. So the solution is a good one, and it would then be the solution to that equation. So now sometimes we might have a variable in the denominator, and that would have to be accounted for as you're looking for that least common denominator. So we have denominators of 2x, 10, and 5x. So that 2, 5, and 10 we know are all common multiples of 10, or common factors of 10, I should say. 10 would be the least common denominator, but we do have to include the x because it exists in some of the denominators. So this time we would multiply both sides by 10x, and in doing that, we would end up with 10x divided by 2x for this first multiplication problem, and then 10x times 3x would be 30x divided by 10. And so I'm not simplifying as I go because I just want you to see the multiplication. And then this would be 10x divided by 5x. And so now we could simplify and see what we have. This would simplify to 5, and this would be 3x, and this would be 2. And so now we have a simple equation to solve. We could subtract 5 from both sides, and then we would have 3x is -3, so x is equal to -1. And again, we want to check it. So let's do that. So I've written out the equation replacing x with -1. And we end up with -1/2 plus 3/10 equals -1/5, which is a true equation if you give them common denominators. So again, -1 is a good solution on this equation. All right, so take a look at this problem. We have denominators of 3, 3x, and 6. And so we need the least common denominator, which would be 6x, because 3 and 3 and 6, the common multiple would be 6, and then we need an x. So we're going to multiply both sides of this equation by that least common denominator of 6x. So now we end up with 6x divided by 3, and again, I'm not simplifying yet because I want you to see the multiplication, plus 6x divided by 3x is equal to 6x divided by 6. And now we can simplify by a factor of 3 here, by a factor of 3 here and by an x, and by a factor of 6 here. So now we have 2x plus 2 is equal to x. And so we can gather the like terms by subtracting an x from both sides. We would leave us with x plus 2 equals 0, and so x must equal -2. And so obviously the next thing we would want to do is check that. So once you pause the video, check that and see if it works. So we replace x with -2, and we end up with 1/3 minus 1/6 is equal to 1/6, and that's true because 1/3 is the same as 2/6. So it works. All right, why don't you write down this problem and give it a try on your own, and then come back and see how you did. All right, so here's my solution, and I checked it and it works, but x should be equal to -25/2. Take a look and see if that's what you got, great, and if not, see where you're different from me, okay? Okay, so that first method was by eliminating the fractions. We were able to isolate the variable. So in this case, we're going to look at factoring as an opportunity to isolate the variable. So the same idea here is that we need to multiply both sides of this equation by the least common denominator. And in this case, the least common denominator would be x squared. So we multiply both sides by x squared. You can see then we would have 5x squared over x squared, which will be a simplifying opportunity. And then that would be equal to 6 times x squared divided by x minus x squared. Okay, so now let's go ahead and simplify where we have that opportunity. And so the x squareds will simplify here, and we just end up with 5. And we can simplify this x and one of these. So we have 6x minus x squared. Now you can see this is a quadratic, so we will be able to factor it most likely. So we just need to put all the terms on one side of the equation and set it equal to 0. So we could add x squared to both sides, and we could subtract 6x from both sides. And so we would end up with x squared minus 6x plus 5 is equal to 0. And so that is a factorable trinomial. We could factor it as x minus 5 times x minus 1. And so we know that this is equal to 0. So the zero product property tells us that one of those factors must be equal to 0 for this to be true. So x must be equal to 5 or x must be equal to 1. Now this is definitely a time where you're going to want to check both solutions to make sure that neither one of them is extraneous. So I'm going to pause the video and let you do that. So I hope you took the time to actually check both those solutions, and in this case, both of them work, so they're both valid solutions. All right, so why don't you give this one a try on your own and then come back and see how you did. Okay, so it looks like we have a factorable quadratic trinomial in 2x squared plus 5x minus 5x plus 2. And so you could factor it to 2x minus 1 and x minus 2, and then isolate the x's to get 1/2 and 2. And then you could go back and check that they work, and in this case, they do. So your assignment today is page 675, 1 through 15. Please make sure your solutions work, and good luck. See you later.